Asaf Toledano, good morning.
Good morning, Ludwig.
Thank you for being with us on the program today at gpsbusinessnews.com. You are Vice President in charge of business development, sales, marketing at a company called WiseSec.
That's correct.
And we're today at Mobile World Congress. So tell me a bit, what is WiseSec and what you are doing?
So WiseSec is all about mobility customer experience. It's a startup company. And when I'm saying mobility customer experiences, I'm referring to location-based experiences in places where location doesn't really work today, which is indoors. A lot of our experiences are heavily impacted by outdoor location triggers. However, when you get indoors, the technologies that are out there have few problems to solve in order to provide the right experience. Technologies like Wi-Fi, Bluetooth, sensor fusion, sound waves, and many more that are trying to do something in this industry or in this vertical. What we do basically is to provide a technology that is based on a client on the device, which fits both Android and iOS. You can see here the example of our retail client. I'll soon speak about the use cases, as well as beacons that are self-manufactured by our company. This is a Bluetooth beacon, but Bluetooth, which is very different from what we normally know. We're actually building the framework from scratch. This is part of the IP, and using that in order to locate ourselves in the overall complex, whether it's a retail store or a defense facility, which is the other use case that we started from, the defense industry. Let me show you how the technology actually works, and I'll start with the retail experience. I've defined here a very simple scenario. It is comprised of check-in notification right here. I will have down there at the end of my booth an electronics shelf, so I'll receive a half a meter coupon, and all these proximities are fully configurable, so you can define as a retailer in which proximity you want that to happen, and all the way to my point of sale, which will be down there, where I will demonstrate a zero proximity, so NFC-like trigger. Although it's based on Bluetooth, that's a non-NFC enabled device, as you can see. I don't have any SIM-based NFC solution here, or sticker, or any other of the NFC replacement. Everything is based on my client that is running on the device. Obviously, the user needs to opt into the service, and it will be probably combined into the retail application with the loyalty points and coupons and whatever, and I will provide them in an SDK type of fashion, or with my full client, the location triggers and the mobile controls that are required to generate the right experience. Okay, so let's see it happening actually. Let me just close the application, and you will see that when I'm standing in the check-in area, I will be welcomed by a notification. That's a personalized notification, taking the information either from my database or from the CRM or loyalty database, the backend systems of the retailer. I can decide to dismiss that and not be bothered again if I'll push the close. If I want to enjoy the coupons or the navigation, I will go into the application. By the way, if the Bluetooth will be down, I will instruct you that in order to enjoy the coupons, you need to take it up, and I will bring you to the right location. So effortless user experience is a very big factor here, and I'm trying to do that with my mobile controls in order to automate as much as possible the experience. Okay, so I can view the coupons that are relevant in the check-in area. I can decide to go to a specific coupon, navigate to the actual store that published this coupon if I'm in the entrance of the shopping mall, for example, or alternatively, go to my regular navigation screen and regardless of coupons, view my retail map or shopping mall map and decide that I want to go to the, for example, electronics area, okay, or anything else that you want to define here. Obviously, everything is configurable, so you as a retailer will be able to load the map, draw the navigation routes inside your store, and the users, once they have the application, will be actually able to navigate according to that. So let me select a specific area, for example, the electronics area. It will draw the line, and it will actually take you Waze-like or Google-like, but indoors. Very precise navigation experience. Let me go back to the promotions to show you the trigger of the half meter that I just spoke about, and I'll switch places here so you can see. And let's walk to the electronics shelf. You will see that only here, in half a meter proximity, the electronics coupon is generated. Again, I can navigate, I can decide to select any one of them, purchase or add it to my cart. The purchase mechanism or the mobile wallet is not our technology, so we are agnostic to that feature. We will select either point of sale or mobile wallet that the retailer will prefer or user customer will prefer. And for us, it's simply an integration. Okay, so let's take away the phone from this half meter trigger, and you see that here it will go back to the previous screen or to anything else, a default screen that you want to show. Again, let's show the experience. So you see it's not something unplanned. So only half a meter. This is something that most of the indoor location technologies doesn't know how to do today. Let's go to the last station here, which is the NFC-like experience. You can see that here nothing happens, and only when I will tap my phone against my Bluetooth, it will trigger the ISIS mobile wallet or anything else that I want to pay with. Okay? If I'll move here, which is 15 centimeters away, it will be back to the same default screen. Okay, so you can see here a geofencing feature as part of my mobile controls that are actually building this experience that is actually an NFC-like zero proximity. This is again something which I believe the industry haven't seen till now, unless then with physical elements that are replacing the NFC chip. So this is the retail experience. I can say that we are already embedded into one of the largest point-of-sale vendors mobile shopping application, which is Retalix. So they took our SDK, plugged that into the mobile shopper in order to make that location aware and attach the mobile phone to a specific point of sale, as well as coupons, location-based coupons. So I'll place that aside and take an Android, so you can see I'm working with both iOSs, and I will show you the defense scenario. So in the defense, what we are doing is to prevent a data leakage or to deploy mobile security policy that is location-based. You can see here that I have currently a default policy. You can see all the features that I'm controlling: the camera, the microphone, the Wi-Fi, the Bluetooth, the GPS, incoming, outgoing calls, all the features that are considered normally in restricted facilities a security hazard. Now, usually without this application, you will need to leave this device at the gate, or alternatively, someone will block your camera. Okay, for example, in the Samsung facility in Korea, you are not able to go with your regular phone. They will place a sticker in your camera. So what I'm doing now, again, everything is happening automatically. Once you install the application, you obviously have the option not to install, but then you will leave the phone at the gate. So you can see that now I'm deploying a default policy. This is not based on my beacon, so I know how to work first with location layers that are not relating to my beacons, but rather to a cell triangulation that I'm building around this building. Okay, and it will apply. So in the regular cell triangulation proximities, I'm not inventing anything here. So between 500 meters to kilometer point something, I will deploy a default policy. And if I move into my facility and be exposed to my beacons, then I will apply and employ something else. So let me show you how it looks. So let me go to a specific room. I'll imitate that by plugging the specific beacon to the power supply. Okay, in this case, USB. And you will see that once it's starting to operate, it will be something like 9 to 12 seconds. The policy will be replaced automatically. I'm not touching anything here, and will free everything except the Wi-Fi. Again, around 9 to 12 seconds. Okay. You saw the switch, everything is green, and other than the Wi-Fi, which is still red, sorry. So let me go to the camera for a minute, just to show you that the camera is now open, and I will soon close that again, so you can see the camera is fully functioning. Let me go to another room, which will restrict only the camera, and I'm leaving my camera open. This is something that a normal MDM usually doesn't know how to do. So going with an open camera and blocking that while it's open and active. Okay? So we'll do that in a minute. We're doing that, by the way, without any root to the operating system. We're not changing the ROM. That's a normal Android version, like the one that you buy from the telecom store. Okay. Again, you will see that in the same resolution of 9 to 12 seconds. That means to take the policy into action. You will see that the camera will be disabled. The note will be in Hebrew, so apologies for that. But you will see that it's blocked, and I will show you also the policy that was replaced. That's, for example, is a room level proximity. That's the normal use case in the defense or restricted facilities. But I can work obviously in any proximity that is required. Let's see. You can see that the camera again is blocked, and you can see that the policy was changed to block the camera. That's our use cases. It's important to say that the technology is already operating in production in 3 defense facilities in Israel. It's being piloted, the civilian, the retail side is being piloted with a very big telecom provider in the States. And we are expanding as we speak into additional pilots in different places around the world.
And you have also been working with shopping mall in Moscow?
Right, so this was just released a few weeks ago. We closed the deal with a shopping mall in Moscow. It's a very big shopping mall with more than 5,000 stores and merchants. Probably one of the biggest malls in Russia, in Moscow, in the Moscow area. And what we're going to do there is navigation and coupons in order to allow the retailers and the merchant to expose themselves in a better way to their consumers. The mall was looking for multiple technologies in the last year or so based on Wi-Fi and others in order to improve the customer experience with the mobile devices. Russia is a market with a lot of smart mobile devices, unlike what we normally think. Russia has a very nice penetrations of smart mobile devices, and definitely a lot of the experience are moving to the smart mobile device, and this is part of their efforts to do that.
And in that case, I mean, you are deploying Bluetooth beacon just based on Wi-Fi?
No. We're actually going to deploy these Bluetooth beacons that you're actually looking at. The beacons themselves are transmitting to a range of 100 meters each. I don't need to be necessarily in the coverage zone of the Bluetooth in order to trigger something. In addition to that, the cost factor of these beacons are very, very low. Actually, for a retailer, we will probably price that with $0 each. And the cost model for us is very, very low, something that the industry, I believe, didn't see till today. Again, keep in mind that the mobile device might be at any point in a exposure to multiple beacons in a certain place. However, part of my technology knows how to prioritize and to decide what reaction needs to happen here versus here. So not only based on signal strength, I'm looking at multiple elements that I'm taking into my pattern padding algorithms in order to decide that here I'm popping up a coupon, here I will place the check-in notification, and here I will do NFC-like experience. While these beacons are transmitting, all of them are transmitting the same protocol in the same distance.
Asaf Toledano, thank you very much.
Thank you.